evening, whenever the heck you're watching this. This will be over the weekend, so you could be doing this at 2 in the morning for all I know. This is special right triangles, the first day of it. And special right triangles, there's only two of them. So your next test is only going to be over two triangles. One of them is a 45, 45, 90 triangle. It's also known as an isosceles right triangle. Okay? If you have an isosceles right triangle, that means that two of the sides are the same and two of the angles are the same, and the other one's 90 degrees. So here's the deal. There is a relationship that exists between all 45, 45, 90 triangles, and we'll talk about another type on Monday. So the 45, 45, 90 triangle, here's the situation. I'm going to use a variable to represent this side. Let's just use A. Okay, so here's the thing. If that's A, this is also A. And this side over here is going to be A, but it's going to be bigger than A because you've got this is the hypotenuse, it's got to be bigger. And if we did the Pythagorean theorem, I could show you, but I really don't want to have to go through all that math and show you. But if I did the Pythagorean theorem, I could show you that this would be A on the square root of 2. Okay? So here's the situation. If you are given this number, let's say I tell you what this number is. Well, if you need to go from this number to this number, you don't do anything. It stays the same. Stays the same. And if you need to go from this number to this number, I'll put the arrow going the other way now, it also stays the same. But if you needed to go from this number to this number, you would multiply by the square root of 2. And the same thing if you were going from this number to this number, you would multiply by the square root of 2. But what if I wanted to go from this number to this number? Well, if you multiply by the square root of 2 going this way, you would divide by the square root of 2 this way. And the same thing if you went from here to here. You would divide by the square root of 2. All right, so that is a complicated looking flow chart, if you will. But basically, if you're given this one, you multiply by the square root of 2 to find this one, and this one just stays the same. If you're given this one, and you need to go over here, you divide by the square root of 2. If you need to go here, you could divide by the square root of 2. But if you went this way already, you could know this one just stays the same as that one. These two are always going to match. So I have some examples for you. And this pretty much runs all the things that you would have to do in this class for special right triangles. Okay? I think I covered all of them for 45, 45, 90 triangles at least. And I tried to represent 45, 45, 90 triangles different ways. This is one way they could show you a 45, 45, 90 triangle. Ooh, I just realized I forgot one. Oh well, I'll show you that later. So this is 8, and if that's 8, this is 8, because these stay the same. And then to get from here to here, I multiply by the square root of 2. Well, we did some work with radicals yesterday. 8 times the square root of 2 is just 8 square root of 2. 8 on the square root of 2. That's the answer. That one and that one. Okay? On this one, to go from here to here, we divide by the square root of 2. Well, again, we did this yesterday in your notes, so we're doing it today in our work too. 6 on the square root of 2 divided by the square root of 2, those things just cancel out. So this side is just 6. And if that's 6, so is this. All right, we come down here, we have 5 on the square root of 2. Sorry, somebody knocked on my door there. So these two have to stay the same. And so if that's 5 on the square root of 2, this is 5 on the square root of 2. And then to get from here to here, I multiply by the square root of 2. 5 on the square root of 2 times the square root of 2. We did this yesterday. Okay? 5 times the square root of 2 times the square root of 2 is 5 on the square root of 4. But we know the square root of 4. The square root of 4 is 2. So the answer to this, 5 times 2, this is 10. That's how that works. Coming over here to this one, this is 3 on the square root of 3. This is also 3 on the square root of 3. And then to get this one to here, you multiply by the square root of 2. You always multiply by the square root of 2 if it's a 45, 45, 90. This is another way they can show you a 45, 45, 90. So 3 on the square root of 3 times the square root of 2 is 3 on the square root of 6. And we don't know what the square root of 6 is. That doesn't simplify. That is the final answer. You do nothing else with that. All right, we turn this over. Got a few more problems here. All right, starting with this one, we've got 6. To go from this side to this side, or this side to this side, I divide by the square root of 2. Well, 6 divided by the square root of 2. All right, we talked about the fact that this used to be acceptable, but a long time ago, some jerk said we can't have a radical on the bottom. So we have to multiply the top and the bottom by the square root of 2. This is 1. You know, square root of 2 over square root of 2 is 1. I can multiply something by 1 and it doesn't change the value. It may change the way it looks, but it doesn't change the value. It's like having 4 quarters or having $1. Doesn't change the value, same amount, just looks different. Okay, so when I multiply this, I get 6 times the square root of 2 on the top. Square root of 2 times square root of 2 is square root of 4 on the bottom. But we know the square root of 4. The square root of 4 is 2. And 6 divided by 2 is 3 on the square root of 2. That is the answer. 6 divided by 2 is 3, and then the square root of 2 stays there. So if that's 3 on the square root of 2, so is this one. It stay the same. Nothing happens. Okay, this one gets you a more complicated answer. Kind of. Not really. It actually has one less step, though. Okay, so to get from here to here, you would divide by the square root of 2. Again, you can't have square root of 2 on the bottom. So you have to multiply the top and the bottom by square root of 2. The top is 5 on the square root of 2. The bottom, square root of 2 times square root of 2 is square root of 4. 2 times 2 is 4. We know the square root of 4 is 2. So if that's 5 on the square root of 2 over 2, some people want you to divide that and do 5 divided by 2 is 2.5. 2.5 on the square root of 2. I don't think I don't like mixing decimals and fractions if I can help it. Okay? So my answer to this would just be 5 on the square root of 2 over 2. I would leave it like that. Mainly because when we get into the next thing, we're going to use the square root of 3 a lot, and you're going to have a 3 on the bottom, and 5 divided by 3 is irrational. It goes on forever. Actually, it's not irrational, excuse me, it's a repeating decimal, and it goes on forever. And that's just not, that's not an exact answer if you do it that way, if you write it as a decimal. So I like leaving it like this. So this will also be 5 on the square root of 2 over 2. If your teacher says differently, do what your teacher says. But for my students, we're going to leave them like this. If they don't divide evenly, we leave them as a fraction. All right, coming down here to this one. This is 4 on the square root of 3. So to get from here to here, I would again divide by the square root of 2. 4 on the square root of 3 divided by the square root of 2. But we can't have a radical on the bottom. So we multiply the top and the bottom by the square root of 2. And so so multiply the top and the bottom by the square root of 2. This would become 4 on the square root of 6. 3 times 2 is 6. And square root of 2 times square root of 2 would be square root of 4. Again, we know the square root of 4 is 2, and 4 divided by 2 is 2. So we got to leave the square root of 6. And if this one is 2 on the square root of 6, so is this one. And finally, we have this one. It's going to work out the same way this one did, except it's going to end up being a fraction like this. So we take 9 on the square root of 3 divided by the square root of 2. We multiply the top and the bottom by the square root of 2. That's going to turn the top into 9 on the square root of 6 and the bottom into the square root of 4. And that's going to turn this into 9 on the square root of 6 over 2. And guys, that does not divide evenly. I don't like mixing decimals and radicals, so I'm not going to. I'm going to leave it as a fraction. We got 9 on the square root of 6 over 2 and 9 on the square root of 6 over 2. Okay, so that is pretty much all of the examples. And you know what I just realized is that I did not make this a 45, 45, 90 triangle. I just realized this is just some triangle. It wasn't even drawn on there. So you know what? Let me change this one to show you something. If we add this on here and we make this a square, a square cut in half is always going to be a 45, 45, 90 triangle. Okay, that's one way, one type of a 45, 45, 90 triangle I did not show you. Okay, so now that you know that, you pretty much know all there is to know about 45, 45, 90, and you hopefully will not have a problem with this part of the unit. Take care, have a good weekend.